All right, today we are going to look at the idea of the angle properties of parallel lines and transversals. So parallel lines, obviously, they have the same slope, they never intersect with one another. And on this diagram, I've shown it as the two green lines. So what we're going to do is we're going to say, what the heck happens when another line called a transversal cuts through both of them? So again, these lines are parallel, and we tend to show that with arrows that we've written on the parallel lines like that. Maybe I should do that in a different color so it stands out a little bit more. So these arrows indicate that these two lines are parallel to each other. They never intersect, same slope, all of that. This third line that I have crossing down in that pinkish color is a transversal. So this would be my transversal right there. So what happens when a parallel line, a set of parallel lines, is crossed by a transversal? There's three important properties that we need to know. The first property is this idea of something we call corresponding angles. So corresponding angles are angles in the same relative position. So when I do this, and I look at this, if I call out this angle here, I'm going to call it angle alpha. So that is to the right of the pink line and above one of the parallel lines. The corresponding angle to that is going to be in the exact same relative position. It's to the right and above. And what corresponding angles theorem, or it's actually a postulate, tells us is that what will happen is alpha is congruent to beta. They're the same angle. It's the same measurement. Because that line is coming through and it's crossing through parallel lines, it intersects at the exact same angle. So what this theorem actually tells us is that corresponding angles and sponding angles are congruent. And it's only in this situation, two parallel lines, and we do that. So no matter what we have, if I tell you that this angle is, let's call this 92. It doesn't look like it's 92, but we're going to pretend for this example that it is 92. Things are slightly screwed up, but we're going to make it work. If that's 92 degrees, then what that means is this angle here that I'm going to label as 2x plus 2, that angle has to be the same thing because it's in corresponding position. It's to the right of the transversal, it's above the parallel line, it has to be equal to each other. So I can solve for x by setting 2x plus 2 equal to its corresponding angle, which I said was 92 degrees. Yay, iPad. 92 degrees. All right, so again, we're going to use our inverse operations. Just going to show you this once in this video. You know how to do inverse operations. So that would give me 2x is equal to 90, because I'm adding 2 to one side, so to get rid of it, I subtract 2 from both sides. So x has got to be 45 degrees, okay? That's a simple way of solving problems. It's an easy way of doing it. Corresponding angles are always congruent, okay? Now, the next concept that we have, we're going to build off that corresponding angle postulate. It is the most important postulate that we have because it's what everything else is based on. So if I go back to this idea of alpha is there, well, whatever alpha is, this corresponding angle has to be exactly the same. Agreed? So if that is the case, then what is this angle here, this beta? Well, that's a vertically opposite angle, right? Like that pause. That's a vertically opposite angle. So alpha and beta have to be exactly the same. So these, because of vertically opposite angles, have to always be the same. What that means is that this angle here is always equal or congruent to the angle that's on the opposite side of the the parallel lines. And that, again, super helpful. This allows us to solve all sorts of more interesting problems where we have one unknown. Let me just go through that here. And I know I just erased that, but you'll be okay. So if I tell you that this angle is 120 degrees, and I want to know the measure of 3x plus 50, if I want to know what x is, right away, we could do the process where we do corresponding angles and then vertically opposite. That's beautiful. That's fine. Or we can just remember that alternate angles will always be identical. Okay? So those alternate angles work. And we could solve doing that. Additionally, we have other alternate angles that exist. There is another set of alternate angles here. We know that this is 120 degrees. Well, so does this one have to be 120 degrees. Now, that is because this is alternate to that, or we've got corresponding angles going on. So again, a really nice, simple, useful trick is that alternate angles anywhere with transversals and parallel lines, alternate angles are congruent. Again, congruent, geometrically equal to each other. The last concept we have is this idea of co-interior angles. Co-interior angles work slightly differently. So I'm just going to do a quick copy and paste here if I can. No, maybe not. Here we go. Let's go up over here and let's look at co-interior angles. Huzzah. Co-interior angles. All right. So co-interior means that angles that are black will not work. Neither will that color work very well. Goodness. So co-interior means that they're in between the parallel lines, but on the same side as the transversal. So again, angles between. Wow, you can see my iPad is working wonderfully today. Yeehaw. Between parallel lines on the same side sweet. On the same side of the transversal, those are called co-interior. And the whole deal with that is, again, using alpha and beta like that, what happens there is always, always, always alpha plus beta have to be supplementary, which means they add to 180 degrees. Again, super useful. We know that if we know that property, we can always use that. The reason why that works comes back to this idea of corresponding angles. If that's alpha and beta, corresponding angles tells me that this also has to be alpha. And then right here, this is angles on a line. Those have to add to 180. This is why that works. So this idea of using concepts we've seen before and kind of pushing them forward to what else does it mean is what a huge part of geometric proof and geometric ideas are. So today, 3 concepts: corresponding angles, angles that are in the same spot relative to the lines are always equal. Alternate angles, angles that are across the transversal from each other, will always be equal. And then co-interior, angles in between the parallel lines, but on the same side of the transversal, are always supplementary. They add to 180 degrees. Now, I hope that's helpful. I'm pretty sure it is helpful. And good luck. And that didn't stop the video.